Right, what I want to go back to now is how you can alter the configuration of the different facades of your building. So although, as I've said several times now, we're not going to start designing this building in detail, but what you might want to do, even at a conceptual level, is have different window configurations, different shading configurations on the different facades. So first thing I'm going to do is go back into our energy settings, and we'll switch off divide perimeter zones here. And that will put us back into our kind of normal configuration around the building. Now, let's say we want to change the glazing on the north facade. So this is our north facade here. And what we can do is, if we have to use tab, select, and try and select that face, which I've got there. Now, where you can go wrong is, if I just deselect, is when you're using tab, it's quite easy to, select the wrong element, or to select, for example, there I've managed to select a floor. Okay, so you just have to really tab through until you think you've got the facade and it's highlighted in blue. Now, there's a few settings you've just got to change. If we go over onto our properties palette here, values, at the moment it says by energy settings. You need to change that to by surfaces if you want to do this level of customization. If you leave it by energy settings, then those settings that you've inserted already in terms of window glazed area, shading depth, etc., will be applied by default. If we change it to by surface, that now unlocks the controls for that individual facade. So we can now change this by that facade. So I've changed that to 20% glazing. Let's take off the shading. Apply. So I've changed that individual facade now, which I think is kind of reasonable, because even at a conceptual level stage, you don't necessarily want the same glazing on all the different sides of the building. Okay, so, but I'm not going to go into any more detail than that. All right, I'm not going to start necessarily changing the different window shapes and sizes on different floors, because I think you're then getting into a much more detailed level of analysis. Okay, just one other thing to show you before we actually run this simulation. If you go into your Massing and Site tab, you've got this button here, which just configures the way you view your mass surfaces. So if you go to Show Mass by View Settings, that will take the view settings that you've got set in your visibility graphics for that window. If we change that to Show Mass, Form and Floors, then you're just getting that kind of the shape of the building. If we change that to Show Mass Surface Types, you've got your windows and your shading, and I tend to find that view works best for me. And if you go to the last one, Show Mass Zones and Shades, similar view, but it's not showing you the glazing in a different colour. Okay, and I just find that the third one there tends to be easiest to understand. It doesn't look like a building, but that's not the point here. Okay, I think we're all done and we're ready to simulate. Yeah. Okay, so next stage, you have to be signed in. So as you can see there, I'm already signed in to my Autodesk account. If you're not, you just click in on there and you can sign in. The simulation is a cloud service, so it's not performing the calculations on your computer, which is great because you're not then relying on the power of your processor. You're using Autodesk's computers to do it, which is brilliant. Okay, so we're all ready to go. We've signed in. We'll go back to our Analyze tab here, and we'll click on the Run Energy Simulation. Just give that a moment. It takes a few minutes because although it's running the simulation on Autodesk's servers, it still needs to package up your building and send it over to Autodesk. Okay, so we've got a few options here. First of all, project. So what do you want to call this project? Not this simulation, but what's this project called? And I'm going to create a new one. I'm going to call it, let's call it University of Sheffield Plaza Hub. Let's imagine that's what our building is called. And what do you want to call this run, this particular simulation? What do you want to call it? And I'm going to call that, let's call that, it was option B1. All right. So we just give it a logical name that means something, and we hit continue. And now there will be a short pause. Okay, so not a lot happened there, but it's gone. If you were looking closely, there was a little bar in the bottom left-hand window just telling you how the progress was proceeding. The great thing is that simulation has now been sent to Autodesk, and my computer is free again. And get back on with some more work. Okay? So that's gone off to Autodesk. Let's send another simulation. So let's tab select this facade. Change that to by surface like before. Let's put that glazing much higher. And let's give it less shading. Okay, so you see I've changed my building there to a sort of virtually a full glass facade facing west. I'll just hit save in case we have a crash. And let's go back to Analyze up here. Run the energy simulation. Oh. That is probably just an internet issue. It said that the service was unavailable. You sometimes get that if Autodesk are a bit busy. Let's just try. That's annoying. Okay, I'll tell you what. I'll leave it for now. Normally, if you just wait a while, sometimes you have to restart Revit. I'm not quite sure why. But let's go and have a look at that analysis that we've already run. So we go here to the results and compare. Click on that. Maximize that. And that takes you into an interface. And if you notice in the bottom right, it's just popped up, option B1 is ready. So what we've got here is all of my simulation projects. Guys, can you stop talking, please? Thank you. So these are all my simulation projects, not just the ones from today. But you see the one that we created today we called University of Sheffield Plaza Hub. And the good thing about creating these projects is it puts them in folders. Okay, so there's our option that we've created today. So I'll click on that, and it's a bit small there, isn't it? Just zoom in on that. And these are your results. So what you get is, first of all, your title. You get a little thumbnail of whatever image was on the screen when you sent the simulation. You get a nice thumbnail of that, so that's quite helpful. And then you get a summary of your building performance factors. So location, weather station, the floor area of the building, the wall area, some of the things like occupancy levels, what are the energy costs. Now, unfortunately, that's always in dollars. Then we pretty quickly get to the really important metrics here. So we get to our energy consumption levels in terms of electricity, fuel, i.e. heating, and total energy use intensity. So we get to those figures. These are, really these are some of the most important results. Then we've got life cycle electricity usage, fuel usage, energy costs. So assuming a 30-year lifespan of this building, that's how much energy it would consume over 30 years. Okay, renewable energy potential. Here, so what this is looking at is if you were to install roof-mounted photovoltaics, how much energy could you produce per year for this building on this site? And that's a fairly accurate estimate. If you were to install wind energy, how much energy could that create? And there's your figure. Then we move down and we've got annual carbon emissions. And if you look at this graph, and in fact what you can do, if you click on any graph here, it will make that full screen. Okay, I'll just go back to that. So color-coded carbon emissions in terms of electricity, fuel for heating, and then those are our positive carbon emissions. And what could be our negative carbon emissions by creating energy on site? So roof photovoltaics or wind turbine potential. And assuming that we took those potential energy creation sources, what would our net carbon dioxide emissions be? That's what the blue is. Okay. Energy use in terms of electricity and fuel, and then there's breakdown of HVAC systems, domestic hot water. We break down into HVAC lighting equipment. So you've got lots and lots of detail. A monthly analysis of energy consumption. Let's click on that. So, this is looking at heating load across the year. What's creating that heating load in terms of heat losses through windows, through the roof, through the walls. Lots and lots of detail. Monthly cooling load. Now, what I should explain here is, with the energy simulation in Revit, because it's about providing you useful information for design, it's not giving you a detailed temperature analysis room by room. So what it does is it looks at the performance of that building and it looks at it on a room by room basis, but what it does, if that room is below comfort temperatures, it adds heating. If that room is above comfort temperatures, it adds cooling. So that's why you always have a heating load and a cooling load, because it will assume that this building is comfortable and this is the heating or cooling you would need to use. What it's not doing, and you would have to use IES for this, you can't use Revit to take an individual room and look at a thermal performance across the year. So you can't look at a temperature plot for a room. It's not what it's designed for. It's much more about helping you to design a whole building. Okay. Many more graphs. Then we've got just the climate data at the bottom. Okay. So lots and lots of information there. Now, what you can do, I'm just going to pop back into Revit, see if it will let us run that simulation now. probably. Looks like it's okay now. Let's call this one option B2. I'm just going to call it highly glazed, just to help me remember. So we'll send that one off, because what I want to do now is compare the two options. Now, here I've compared B1 and B2 by changing the glazing. You could, of course, compare option B with option C. Option C is a building of a completely different shape. Right, let's go back into our results and compare. And it's not come through yet. Okay. Well, we'll have to wait for that to make its way through. Let's see what I've done. I've put it in the wrong. Can you see? There it is. I've put it in the wrong project. So I didn't put it in the project University of Sheffield Plaza Hub. I've put it in option B project. But anyway, what you can see, 60%. You see that it's calculating. Okay, so it's busy working it out. 62%. So you get that kind of live update on, you know, how far through is it. Okay, let's wait for that a little while. Okay, what we'll do, next thing that is useful, if I go into option D here, which is an option that I ran previously, and let's compare option D with our option B1. Now if we use Control to select these two options, and we click on the compare, it will now put both options side by side. So we're now comparing these two different options. Now what would have been helpful is if with my option D, if I'd made that view similar sort of size to this option. But anyway, we've got the two options, and we can now immediately start to make comparisons between energy use intensities of the two different buildings per square metre per year. We can look at this sort of life cycle costs, renewable energy potential. So if you see, for example, here, in our option, so that's a bit small, in our option D, it would suggest that we've got much more potential for photovoltaic, which kind of makes sense because it's got a bigger roof. So we get that level of analysis, and then we get the comparison of all those different metrics that we were looking at before. Okay. So that's really useful. You can compare as many as you want at the same time. Now, if we want to export that, we go to the Export tab, and we can export that report as a PDF, which is quite simple. If we just select one option, option B now, and go back to Export, under the options, we can also export that as different energy file types. So GBXML, DO2, Energy Plus, GBXML, Geometry. Now you wouldn't normally need to do this, but if you were interested in taking that energy model into a different software package, this is an easy way of exporting the energy model, which will allow you to import it. Okay, so it looks like our option B is finished. So let's just compare those two. And you see we are getting a difference. The building is exactly the same size. One's got huge west-facing glazing. And we are certainly getting, which one's which? The highly glazed one seems to be using more energy. And I think if we went to the cooling loads, let's just go down, monthly cooling, think we'd probably find that we are probably getting a lot more heat through those windows, and that's contributing to a cooling load. Okay. So, quite quickly there, but we've run the analysis there, we've compared two different design options. It only took us about 20 minutes to compare two options. So I hope you can see the kind of the potential there of being able to very quickly simulate energy performance. If you think before we had these tools in our hands, we would have been needing building services engineers to provide this level of simulation. But now we can just do it ourselves.